Okay, hi guys, so we'll be continuing on seeing more on homogeneous chemical equations. So let's get started. So suppose we have CH3COOH in aqueous phase, we have H2OL, then it is getting dissociated into CH3CO minus aqueous and H3O plus aqueous. Then what would be the Kc of this reaction? Kc would be CH3CO minus aqueous multiplied with H3O plus aqueous divided by CH3COOH aqueous. And we won't be writing the concentration of water as it is present in excess quantities. Now let's see another equation. We have CH3COOH getting reacted with C2H5OH aqueous and forming CH3COO C2H5 aqueous plus H2OL. So in this case, Kc can be defined as CH3COO C2H5 aqueous divided by, we won't be taking the concentration of H2OL as it is insignificant, as it is the concentration of H2OL won't be changing considerably during the course of reaction or at the equilibrium point, so we actually ignore that and we just write the concentration of remaining reactants or products. Okay, so here just writing here that water is a solvent, hence we do not include that. So in the above two reactions, water is taken as a solvent, as we have written aqueous in CH3OH, so no effect on further formation of H2OL in the product. So we have everywhere written aqueous phase. So in aqueous phase itself means that water is used as a solvent, so we won't be writing, or rather there is no effect on further formation of H2OL even in this reaction, so we don't include that even in this reaction. Okay, let's see more examples. We have CH3COOH L getting reacted with C2H5 OHL, and now this is getting formed plus some H2O L is also getting formed. So in this reaction here water is not initial solvent because we are directly using pure reactants, not the aqueous phase of these reactants. So here water is not initial solvent, as CH3COOH L is pure, and second is water is formed as a product, that is H2OL. Okay, hence Kc for this equation would be, or this reaction rather, would be CH3COO C2H5 L multiplied with H2OL divided by CH3COOH L multiplied with C2H5 OHL. Okay, next, that this actually equilibrium mixture contains 4 substances and no substance has independent existence. Okay, so next let us see heterogeneous mixtures, heterogeneous reactions. And why in the previous equation, why did I say that no substance has independent existence? Because everything is happening at equilibrium. That's why we are saying the statement that no single compound out of the 4 has independent existence. Everything is happening at equilibrium. So now let us see heterogeneous chemical equations. Okay, so we have CaCO3 in solid phase getting converted into CaO solid plus CO2 gaseous form. So here Kp would be nothing but partial pressure of CO2 gas and Kc would be concentration of CO2 gas. Why we are not taking the solids? Because we are taking Kp and Kc in gaseous forms. Okay, so delta Ng would also be 1 as the moles of gaseous products is 1 and moles of gaseous reactants is 0. No gaseous reactants is present in this case, hence this would be the constants. Next, if we see this compound NH4HS in solid and it is getting converted into NH3 gas plus H2S, then what we can say that Kp in this case would be partial pressure of NH3 multiplied with partial pressure of H2S, and Kc in this case would be again the concentration of NH3 gas multiplied with concentration of H2S gas. Okay, now let us see another case where we have a box wherein we have CaCO3 present, which is a solid, and this which will release CO2 gas, and CaO would also be present here. Okay, so we can say that CaO and CaCO3 are independent entities and there is no change in mass or volume, hence the density remains constant. Okay, so what happens in phase equilibrium then? So in phase equilibrium, so supposedly we have H2O getting converted into H2OS or H2OG maybe. So what happens here is Kp would be again partial pressure of H2OG and Kc would be again concentration of H2OG in the above case. Okay, now if you look at the formula of molar concentration, so formula of molar concentration is simply we have number of moles divided by volume of solution. Number of moles can be written as given mass or weight of substance divided by molar mass of that substance, okay, into divided by volume which is already there. So weight upon volume can be written as, so in this case if we had CaCO3 as solid, so in that case we can write simply that weight upon weight of the substance divided by volume, that is nothing but weight of CaCO3 divided by volume of CaCO3. We can write that as density divided by molar mass of CaCO3. And as we know that during the course of the reaction, mass and volume of CaCO3 are not changing, hence densities are also not changing, hence molar concentration is also not changing. So for pure solids or pure liquids, their concentration is not taken in equilibrium constants expressions. Equilibrium constant expressions, because density or molar concentration of solids oblique liquids remains constant during the progress of reaction. Hence, their concentration is not taken into account. So with this, we come to the end of this lecture. In the next lecture, we'll be seeing more examples on the same lines. Till then, good luck and goodbye.